Hey, so it seemed like a couple students were struggling with computing the ANOVA for Module 11, and I just wanted to walk you through a quick video about how that's done. So remember, the problem here is that some research indicates that depending on how often you use Facebook, you might have higher or lower grades. And so we've collected here 4 groups of students: non-users of Facebook, rare users, regular users, and those who are addicted to Facebook. And then we've computed their grade point averages. So each of these groups has 10 students, and their GPAs are listed in the columns underneath those category headings. I've transferred those scores over into this Excel spreadsheet here, and I'm going to walk you through the process of computing the ANOVA. So I've taken the formulas for the ANOVA out of the formula sheet, and you've got them here. So let's start by computing the sum of squares total. This is the sum of x squared minus g squared over n. So I've got here just a note that we need to compute the sum of x squared. That's right here. And what that means is squaring each x and then summing them up. So the first thing we need to do is multiply each of those times itself. So this is 3.7 squared. And if I just do that for every one of these scores, and I do it for each of the scores across all the conditions, then we end up with all of the x squareds there. Now, if I want to figure out the sum of all the x squareds, I just have to take the sum of those, and those, and those, and those. And that's the sum of x squared. Now we need to subtract from that g squared over n. And this is the big N, the total number in the whole study. So g squared is the grand total of all the scores. I'm going to just figure out what that is right here. G is the grand total of all the scores. So these are the original scores. Sum them all up. And G is 129. In order to figure out this whole component here, we have to square that and divide it by 40, because there's 40 people in this study. So we multiply that by itself and divide by 40. And that comes to 420.423. And then we just take this first component that we computed here, and we subtract from it this component that we just computed here. And so in order to get the sum of squares total in this box, we equal that is, equals the sum of x squared minus g squared over n. So there you go. That's the sum of squared total. In order to compute the sum of squares between, we have to do the sum of the t squared over n for each group. Now what that means is for each group we have to figure out what is the t, what is the total for that group. Square that value and divide it by how many are in that group. So let's just start there. Let's do this for each group. The sum of the scores in this group are this, the sum of all those. So the sum of all the scores in the first group is 37.1. This is t. I'll just, I'm going to leave the word sum there, but just so you know, that's t. I'm going to leave the word sum because I'm also going to want to sum these. But then what we need to do is square that for t squared, so we'll equal that times itself. And then we need to divide it by 10 because there's 10 scores in this group. So we take that and we divide it by 10. And we're going to carry this over and do it for each of the other 4 groups. And now what we have is t squared over n for each group right there. Each of those are the t squared over n. We need to sum them up. We add up those 4 values. So the sum of t squared over n, I'll put down here, the sum of t squared over n is equal to the sum of that, and that, and that, and that. And so that comes to 425.687. That is the first component of the sum of squares between. Now the latter component is g squared over n, which we already did here. So we already have that here, g squared over n. All we have to do is subtract what we just computed minus what we did before. So the sum of squares between equals what we just did minus what we did before. And that's 5.26. Then if we do the sum of squares within, that is the sum of squares for each treatment added up. Now, I didn't give you the formula for the sum of squares in each treatment. That's the same formula you've been using for a long time now. So back here under sum of squares, for each treatment, you can use this computational formula. You could use the definitional one too if you want, but I'm going to use the computational formula for each of the groups, which is the sum of x squared minus the sum of x squared over n. So we've already done here part of this. Look, this right here is the x's. This is the sum of x. This is the sum of x squared. And this is the sum of x squared over n. So that already is the latter half of your formula right here, the sum of x squared over n. Now all we have to do is take the sum of all the x squareds. We've already squared each x, so all I have to do is sum those up. The sum of all those x squareds is 138. And then, to figure out what is the sum of squares for this group, I just take, as the formula says, the sum of the sum of x squared, which we just did, minus the sum of x squared over n, which we did before. And so we just take what we just did minus what we did before. Now, this right here is the sum of squares for this non-user group. This is the sum of squares. I can take these values right here, and I can do that across for each of the other conditions, and these are the sum of squareds for each of the 4 conditions. And what I need for the sum of squares within is to sum up the sum of squares for each treatment. So I sum up each of these values together, and the sum of squares within equals the sum of this plus this, and this, and this. 5.69. Now we can compute the degrees of freedom. The degrees of freedom total is the total n. Remember, there's 10 in each group. There's 4 groups, so that's 40 minus 1. So I'm going to say that's 39 is the degrees of freedom total. And then the degrees of freedom between is k minus 1. K being the number of conditions. There are 4 conditions. Minus 1 is 3. So I'll just put that here as the degrees of freedom between. And then finally, the degrees of freedom within is the sum of n minus 1 for each group. So n in each group is 10 minus 1. So 10 minus 1 is 9. 10 minus 1 is 9, and 9 and 9. So that equals 9 times 4, or 9 plus 9 plus 9 plus 9. And that's 36. Now remember, when you compute the mean squares, or the variance, as we've called it for many modules now, all we have to do is SS over DF. In order to figure out the MS between, we just take the SS over DF for between values. So that equals this divided by this. And in order to figure out the mean squares within, we just take SS over DF for mean squares within, and then that equals 0.158, and then the F statistic is to take the between divided by the within, so equals that divided by that, and you've got 11.1 or so. There's going to be some rounding error. I didn't round at all in the whole computation of everything I did up here, but when I created the module answer key up here, I did round some, and so you'll see that perhaps what you computed, based on how many decimal places you carried your computations through to, you might find that you have slightly different values. Indeed, when I didn't round at all here, I have slightly different values, but they're approximately the same as those that are given in the answer key, and so you should be able to figure out now how to compute every part of your ANOVA based on whether you're rounding or not. It's going to be a little bit different, but you should be able to figure out now, based on this video, how you can compute the ANOVA. Okay, take care.